Welcome to our Succeeding with Forecast Pro webinar series. In today's webinar, we're going to discuss multivariate modeling.
Hi, my name is James Berry, and I'm the Director of Training here at Forecast Pro, and I'll be guiding you through the webinar today. My colleague Franklin is assisting me, and he's monitoring the chat and will help you with any important notes, questions that you have, or posting any important links in the chat as well. Let's cover a few housekeeping notes. This is an ongoing webinar series. We run these once every quarter. Our next webinar will be in August, and we'll be covering external data. We have a registration link that is available now, and my colleague Franklin will post a link to that right now in the chat itself, so please click on that and sign up for our next webinar. We also have a concurrent webinar series that focuses more on the statistical models and how they work. And as a companion to this webinar, which covers multivariate forecasting, we're going to have another webinar in June on multivariate forecasting that really deep dives into the statistics and the model specifications. This webinar will focus on the practical functionality of multivariate, whereas that webinar will focus on the statistics and the models themselves. So I highly recommend you sign up for that. It's a great companion to this webinar that we are running today. It is also free, and my colleague Franklin will post a link to that webinar in the chat as well. And speaking of the chat, throughout this entire webinar, please, if you have any questions or comments, type in the chat. Franklin will be able to answer them. We are also going to finish with a Q&A session where we will ask for your own questions, and we'll try to answer them as well. So please, throughout the session, use the chat built into Zoom. You can see here how you click on it here, and we will try to answer any of those additional questions at the end. So with the housekeeping out of the way, what is the actual agenda that we're going to cover? So we're going to start with an introduction on models, multivariate versus univariate models. So we'll talk about that. Then we will dive into some examples using Forecast Pro, showing you the different types of multivariate models that we have built into the system. We'll wrap it up with some conclusions of what we've covered today. And as I mentioned, we will then finish with questions that you type in. So with that said, let's go ahead and dive into the webinar.
To begin, we're going to discuss the different model types that are available within Forecast Pro. From a big picture perspective, there's really two ways to generate a statistical forecast in Forecast Pro. One is through univariate or time series modeling. The other is through multivariate. So what's the difference between the two? The univariate or time series models generate a forecast based off of only one thing, your historic data. They review your historic data, they identify any patterns in your historic data, and they continue those patterns into the future with the forecast period. Some factors that they consider are things like what's your average volume per period, do you have any trends up or down, or do you have any seasonality or patterns that repeat themselves year over year? So again, they're identifying these different patterns in your historical data and they're continuing them into the future. And because these are looking solely at your history, we can generate these models automatically. So when you use our expert selection system, they are using univariate models to generate the statistical forecast. So here's a sample of some data. We would look just at the historical data. So we would look for things like a trend line. Here you can see this data is growing fairly consistently. Another pattern that we might look for is the seasonality. So we look, is there a pattern that is repeating itself year over year? And then we would continue that pattern into the future. So what are some of the pros and cons of univariate modeling? Well, the biggest is that it is automatic. When you push the Read and Forecast button within Forecast Pro, the expert system will automatically generate statistical forecasts for you. So at scale, with large-scale hierarchies, with thousands or tens of thousands of data sets to forecast, this is really the big advantage of univariate modeling. The other big piece is that it only requires your history. So history is something that you control and you have, so you can use your own historical data to generate the forecast. So it doesn't require any outside information or any other additional data gathering. So the data requirements are small and it's very automatic and quick to do. So what are some of the downsides? Well, the biggest is that it is looking at nothing beyond your historical data. So if you have knowledge of your business, if you have knowledge of what's driving your business, that information simply is not incorporated into these univariate models. You are relying just on whatever's happened in the past is going to continue to happen the same way in the future. And if this is true, these models work great automatically. But if it's not true, if you understand your business better, if you know your business, if you know changes are coming, you can't use a univariate model to incorporate that. The other big downside is that univariate are really designed for short to medium range forecasts, 1 to 2 years out, because it doesn't see changes coming. It is simply using your historical patterns to generate a forecast going forward. And so if you want to do a longer term forecast, you would need this kind of information about where your business is going, and univariate is not meant for that. So with that said, let's look at the alternative, which is multivariate models. The biggest difference is that we are now able to incorporate these drivers that are affecting your business into the model itself. We're no longer looking solely at the history. We call these drivers explanatory variables. So we are going to build a much more complicated model that incorporates all of this outside business information to hopefully build a better, more accurate model. In addition to business-specific drivers, you can also do lagged drivers in order to generate a better forecast. For example, we had a customer who made ceiling tiles for commercial real estate buildings. Now, these are obviously finished goods, and so they would be going in last when you're actually building a building. And so one of the things they could look at as a lagged variable would be commercial building permits. They know, a certain number of building permits are pulled, which means a certain number of commercial buildings are going to be built in a given area. But on the day that a commercial building permit is pulled, you're not going to be ordering your finished goods. You know that there's going to be a lag. In this case, it's usually a 9-month lag between the time that the building permit is pulled and when you're ordering the finished materials that go into it. So using these lagged variables, I actually know what's going to be happening in the future, and so I can leverage that into my model. And speaking of timing, the other advantage of multivariate modeling is that it is designed for longer-term forecasts. If you're going out 2 years or 5 years or 10 years, univariate or the time series methods just aren't designed for that. Whereas with multivariate, because you have these drivers, you can make predictions of changes to the drivers, which can help you predict changes in your business itself. So what are some examples of these drivers that we can incorporate into our models? Well, there's really two types. There are internal drivers that you control with your business and external drivers that you don't. So internally, the biggest driver that most people always talk about is price. So for instance, tomorrow, if you were to double the price of all of your products, that would greatly influence your sales. But this is something you control. You can set prices, and so you can use that to do this kind of building. Other internal variables would be things like digital marketing campaigns. If you run a big digital marketing campaign for some of your products, you would expect sales to increase. And so knowing the timing and the size of those campaigns would be important to incorporate in the model. Another would be store count. If you are selling in a retail environment and your business is growing and you're opening more and more stores around the world, well, this would obviously impact the driving demand of your business. And so you want to be able to monitor something like that. And then there's the external drivers. These are usually big macroeconomic information, things like GDP or disposable income or population growth. These are big macro factors that can affect not only your business, but the business environment in a whole. And if we can gather some of this information, either through government sites, or you can purchase it through companies like Global Insights or AC Nielsen, and you can purchase these kind of big macroeconomic data, you can use this and leverage it to generate a better, more accurate forecast. So again, these drivers can come from anywhere. They could either be internal and controlled by you and your company, or they could be external drivers that we want to incorporate into the model itself. So what are some of the pros and cons of multivariate modeling? The biggest is that you are incorporating more information into the model, and that's key. You can hopefully build a better, more accurate forecast by not solely relying on what you've done in the past, but by incorporating these drivers that are actually affecting your business itself. And because you're using these drivers, you can also use it to predict changes in the future. Remember, univariate is just going to continue the patterns over and over again into the future. And this here with multivariate, you can actually use these driver variables to predict changes coming up in the future itself. So your model is not sort of beholden to just whatever you've done in the past. And given that, you can then perform what-if scenarios. What if our store count grows by 20%? Or what if we raise our price by 10%? What would happen? And so we can play out these what-if scenarios by building these models and looking at what's happening here as well. And then as mentioned, it is better for medium to long-term forecasts if you're going 2 to 10 years out, whereas the univariate just wouldn't allow that. It's just not meant for those kind of longer-term forecasts. This is something that multivariate can do. So those are the pros. What are the cons? Well, obviously, the first con is that it requires a lot more data. So your history you most likely have. But if you want to build these models, you need access to these driver variables. Now, obviously, the internal driver variables you have some control over, something like prices, something that you actually dictate at your company. But if it's some of these big macroeconomic data, this is something you're going to have to actually go out and find from either some sort of source or actually go and purchase it. So there's a lot more data that's required. It also requires more input from the forecaster. Whereas the univariate are automatic and will generate a forecast, these multivariate models require much more input. You need to tell it what driver variables to use and in what quantities and things like that. And of course, this then limits your ability to automate these models. Depending upon which model you use, there's more automation than others, but it is going to require some work from you as the user, as opposed to just pushing a button and the univariate models will generate a forecast for you automatically. So there are some pluses and minuses to these models, but if you can take advantage of them, you can build much more robust and complete models using these multivariate modeling techniques. And so now that we've seen the pros and cons, what are the different types of multivariate models that are built into Forecast Pro? The two primary multivariate models in Forecast Pro are Dynamic Regression and Multivariate Machine Learning. Let's take a look at these one at a time, starting with Dynamic Regression. More people are familiar with regression in that it is building a linear relationship between the driver variables and the dependent variable that you are trying to forecast. So what that means is that as I raise or lower one of my drivers, that is going to either raise or lower my forecast. There is a straight linear relationship between the two of those. Now, in addition to just the drivers, in dynamic regression, we can also include things like lagged variables, which, again, as we discussed, we could use for building a more accurate model. We can do dummy variables for spikes. So if you have one-off events or one-off spikes, we can put in these dummy variables into a regression model. And we can also incorporate lagged autoregressive terms. So if there's some pattern in the data that you're trying to forecast and your drivers aren't explaining it, these lagged autoregressive terms can hopefully fill in the gaps in those patterns that you are missing. As we said, dynamic regression is building a linear relationship between your driver variables and the variable that you're trying to forecast. So for example, if my prices go up by 50%, this would result in my sales going down by 35%. So we can see this one-to-one relationship of prices go up, sales go down, and this kind of linear relationship is something you can see in the models and that you can view when you're building these models itself. So for example, we can see this in action here in a graph. We would see here at this point that's modeled on the graph that you can see that there was a price increase and all of a sudden there was a big drop in the data. If I was looking just at the history, if I was using a univariate model for this, it wouldn't really know what caused this problem. But by building a multivariate model and having price as one of my drivers, I would see that my price increased, and then I would have a negative correlation to my actual sales themselves. Now, how is this different from our other multivariate model, which is a multivariate machine learning model, or an MML model? Just like with regression, you can incorporate multiple streams of data into a single model. So we're going to have all of these different drivers that will be added to the multivariate machine learning model. Now, where MML is different than a regression model is that the MML models will actually determine which drivers to use. So in a dynamic regression model, you actually have to tell Forecast Pro which drivers to use and which not to use. But with an MML model, you can actually add all of your possible drivers, and the model itself will automatically pick what it thinks are the important drivers. So there's a big advantage to this in that it automates. You just give it a list of all the possible drivers you would want to use, and the MML model itself picks which to use. So there's a certain amount of automation that goes into it. And this allows you to apply the MML models on a much broader base of items as opposed to dynamic regression where you might have to build these models one at a time. Although we'll see in our examples that you can automate some of this, but with the MML models, there's a lot more automation that goes into it. But the biggest disadvantage to an MML model is the lack of visibility into what's actually being built. So unlike in a dynamic regression model, where there is a clear linear relationship between the drivers and what you're trying to forecast, and you can see that in the model, with an MML model, it is much more of a black box. It simply picks which drivers it wants to use, and then it builds a model based off of that. So what does that look like in practice? So in a very simplified example, a machine learning model is really just trying to take all of the data you give it and to group it together into different boxes. So here is a very simple example that we would see. Imagine we had a bunch of flashcards. Some of them had bananas on them, and some of them had apples on them. And so the machine learning algorithm would try to categorize the data. Maybe it would use color, so the apples are red and the bananas are yellow. Maybe it might use the outline of the shape. The apples look one way and the bananas use the other. But the whole idea behind a machine learning model is to try to take all the data you give it and to try to organize it in some way. Now, when we talk about a multivariate machine learning model, if we take those same data series, let's say that represents our historical data, and we add a driver variable, in this case it'll be represented by these green pairs here. So we've added a driver variable to the model itself. Unlike with regression, where we're going to build some sort of linear relationship to it, in the machine learning model, that's not the case. We've simply added more data from which to group the data together. And so instead of just having apples and bananas, we now have apples, bananas, and pears. And so the machine learning model runs, and now we have grouped it into 3 different groups instead of just 2 groups. And so there's no real relationship between the driver variables and what you're forecasting. It simply represents more data from which to build the model off of. And that's key. So while it can be automated and it will pick which of the drivers to use and how to organize everything, so you don't really have to do anything, there is no visibility into how is this actually affecting my business. Simply the model is figuring all that out for you, and you don't really have much interpretation other than here's what the forecast will be. So it's much more of a black box, but the big advantage is it could tell you what drivers it thinks you should use, and it can be automated, so we can apply it to a lot more data itself. So now that we have an outline of the 2 multivariate models, dynamic regression and multivariate machine learning, let's look at some examples. In today's webinar, we're going to focus on 4 examples. We're going to build a single regression model. We're going to build a single multivariate machine learning model, just so you can see what the 2 models look like in comparison to one another. Then we will actually take those models and show you how you would use this in practice when you have a full-scale hierarchy. How do we use regression when we have a full-scale hierarchy? We need to apply this to multiple items. And how do we use a multivariate machine learning model when we have a hierarchy and we need to apply this to multiple items? So we're going to see it one at a time, and then we're going to see it in practice, each how we would do this at scale. So we'll begin with the single dynamic regression model, where we're going to look at how the model is built and how we would interpret the results and determine those linear relationships between the drivers and what we're actually trying to forecast. Okay, here we are in Forecast Pro, and for the first 2 examples, we're going to use this data set here. Now, this is real data. It's monthly. It comes from a small independent toy company, and we're looking at sales of a single SKU that they're selling. If we look at the data, you can see it runs from September of 2023 through the end of 2025, so just over 2 years of historic data. And if you actually look at the data, what you can see is that starting in 2025, there was actually a significant drop in the sales of this particular product. And if we look at just the time series or the univariate forecast for this, you can see it's just predicting this kind of flat forecast at this new level that's going on down here. But if you worked at this company, you would know what was actually happening here. And so they've brought in some driver variables to hopefully help explain what's going on here. So let's take a look at the helper variables that we have. They've brought in 4 different helper variables. Some of them are internal and some of them are external. We'll start with the price. Now, this is actually the price they charge the different retailers. So their list price is roughly $20. But as you can see, the price fluctuates. What they actually charge the retailers themselves, it fluctuates between somewhere around $12 up to about $16.50. And so you can see the price varies by month, and that comes down to the fact that they do discounting in order to promote different products. And to account for that, they've actually brought in the average discount per month, and you can see that some months they have very little discounting, but other months they have much higher discounting, of 30, even up to 35% of the product's price in order to try to move this. So they're incorporating price in 2 different ways. They have the price that they're charging the retailer in dollars, as well as the average discount they're giving to their retailers on a monthly basis. Now, the other thing that's driving this, and is probably one of the reasons that we're seeing this decline, is the store count. This is the number of stores that they actually sell to. Again, this is a small company, and so they're selling to just independent retailers. And as you can see, it was pretty consistent, but then starting in 2025, you can see there's been this downward trend. And more importantly, they are predicting that there will be an even steeper drop at the end of 2026. So in their scenario planning, they're currently selling at this level, but they do expect that there will be an additional drop going forward. And again, this is something that's semi-controlled because obviously it's the number of stores they're selling to, but this is obviously up to the retailers they're selling to of who's going to carry their product. So it's somewhat in their control, but not 100%. And then there's the big macroeconomic data, which is disposable income. So this is real disposable income here in the U.S. They gathered from just public government data. And as you can see, it's growing. And so you can see there's this upward trend. But the idea being that as people have more disposable income, there is a greater sort of desire to consume products, especially sort of products like this, which are just toys, and that will actually increase the scenario. And what I've also done here is I've actually loaded the same SKU in 3 different times. So you can see here we have 1, 2, and 3. This is exactly the same data set, but I've loaded it in multiple times. This way we can try different scenarios, different models, and see how they perform going forward as we add this information in. Now, for this first example, we're going to work with dynamic regression. And so if we were going to build a regression model by hand, we'd go over here to the forecasting tab and click on dynamic regression, and we would create a regression model itself. You can see we have the explanatory variables that we have available to us. We also have an important option here, which is the auto dynamics. So in Forecast Pro, if we want to try to automate this a little bit, in addition to the driver variables, we could let Forecast Pro work out all the other pieces, or we could also build those by hand. For instance, adding constants or trends or lagged variables, we can put those in as well. If we were going to start with a very simple model, we would pick just a single explanatory variable that we wanted to use. So for instance, we could use just price. That's kind of the common one. And then in a typical way that we would do this is we would then add the other driver variables to the model, but we would turn them off. And we do that in Forecast Pro because there are certain tests that will be run on these to say, hey, if we use these, would it actually improve the model or not? So there's some tests that Forecast Pro can do behind the scenes. I'll turn auto dynamics off and I'll just do a constant here just to normalize this because again, all of these are in different units. So price is obviously in dollars, store counts are in counts, disposable income is in dollars, but average discount is a percentage. So we need this constant to kind of normalize everything. And so we would build a very simple model this way, and we could go ahead and build it, and you can see it would build a very different model. What we would want to see, of course, is the model details down below to look at that linear relationship between our driver variables and what we're trying to forecast. In this case, you can look at price and we can actually see the coefficient. This is how our linear relationship works. So it would be if we increase price by 1 unit, what would happen to our overall volume of sales? In this case, it's minus 8,180. What that means is for every $1 increase in price, we would expect to lose 8,180 units of sales. And so you can see here, this data is on a basis, certainly recently at about 30,000 per month. And that would make sense. This product is roughly $20, or what we're charging is between $12 and $15. So obviously a $1 change is a big change, and raising the price would decrease our sales. And that's what we would see with a regression model, is we're actually going to be able to see what is it that the impact of the drivers has on our data itself. And so we actually can see with this coefficient what the impact would be and how it would work. And it works exactly as we'd expect. You increase the price, you decrease your sales, and this tells us how much it affects it. So we could do our kind of scenario building. Now, I've actually gone ahead and created some sample regression models, and this is how you would want to do it in practice. You can see here we have some that are just our price and our discount structure. We have our price, our store count with auto dynamics turned on, and just store count with our auto dynamics turned on. And so what I could do is I can come over here to my scenarios and try one model at a time. So price and discount here, that's scenario 1. I could pick another one over here, which would be my store count and auto dynamics over here. And then I could put on my third, which is price, store count, and auto dynamics over here. And so we could then take a look at what would these different models look like. So over here, where we're just doing price and discount, you can see that the price obviously is negative, as we would expect, but the average discount has an even bigger coefficient. And what does that mean? Well, remember, the discounts are as a percentage. And what that means is if I give a 1% discount, I would expect sales to drop by 89,000%. Because again, as percentages, just giving small percentage discounts would reduce this in huge amounts. So we want to look at something like that. So again, discounts, the more discounts I have, the less sales that I would have, which is what we would expect. If I come over here, we can see our store count. This goes in the opposite direction. If we look at our store counts at our data itself over here, you can see we're running about, we're just doing about 95-ish, and now we're kind of in the 80s, and we're expecting to drop down to about 80 per. And so if we look at this, you can see that adding one store would increase our sales by about 3,500 units per month. And that makes sense, right? As I sell to more stores, I would expect to sell more items. And so we can see that here. And then if we add price and store count in the auto dynamics, you can actually see the forecast here. Again, store count is positive, price is negative. But what you'll actually see with the two of these in here is that actually price, it's flagged as red over here because it's not statistically significant. So when we did store count and price together, they're actually kind of, the price just isn't really helping. It's the store count that's driving. And this highlights one of the important parts of doing a dynamic regression model. We get insight into what happens when we put these different drivers in there. We can see the different coefficients and the effects that they have on them. But I have to build multiple models. I have to build them by hand, and I have to make some judgment calls. This doesn't seem statistically significant, but we do know the price that we charge probably is a true driver of our business. And so should I use that or not? And so I'm doing a lot of manipulation of the models by hand. I'm coming in here and picking specific drivers. I'm doing a lot of tests by hand, but I am gaining a lot of insight into this, which is how are these different drivers affecting my business and how is it going to work going forward? And where we can really see the difference is if we compare this store count, and I'm going to actually go ahead and remove this modifier and go back to our univariate forecast. This is just our time series forecast that's coming over here. You'll see it's basically saying, okay, what we've been doing for the last 6 or 7 months, we're going to keep doing going forward. Whereas if we take into account the store count amount, which we know is going to decrease, you'll see it continues this downward trend. And so by overlaying our business knowledge on top of this, we're able to move beyond just the univariate of what's happened in the past to know what's going to happen in the future. So here's one of the big reasons that we would use a multivariate model is that we have the ability to come in here, and if we know our store count is going to go down or if our pricing is going to go up, it's going to have an impact on our forecast, and we can build that into the model itself. We just saw a single regression model, so now let's look at a single multivariate machine learning model, how we would add different driver variables to it, and how the model itself will spit out the results. So now we're back in the same data set, and how would we use the multivariate machine learning to forecast this same data? Well, what we would do is we'd go up here to our machine learning option, and we don't want automatic because that's going to build a univariate machine learning model. What we want to do is click on manage to build a multivariate machine learning model. And what you will see is just like with the dynamic regression box, we're going to create a custom multivariate machine learning model. But what we can actually do here is we actually just, instead of adding them to the model, we actually just pick which explanatory variables we want the model to consider. And so we can actually just go ahead and add every single one of our 4 explanatory variables. So we can basically say, let the model pick what it thinks it should actually do. So we can come in here, use the same driver variables for this data, but the model itself is going to pick which one it's going to use. Now we could just do one, right? So we could come in here and just do price and see if that's important. And so if we go ahead and say, okay, we can come and look at the model, and it did in fact include price as one of the features. We'll talk about this more in a second. Or what I would most likely do is once again come up here to manage, and I would add every single one of these explanatory variables and let the model decide which one it wants to use. So I can go ahead and say okay again. And now it builds a new model. You can see it does include store count over here as part of the model, and price is part of the model. But and you can see average discount in here, but you don't see disposable income at all. It's not added to the model. Now, can we tell the linear relationship between the two of these? No, not at all. And does these percentages, store count is 77%, whereas price is 1%, does that tell us anything? No, not really either. What we can really only glean from this is that it included the series of store count, as well as average discount, as well as price. And so what that means is this data series has 28 months of historical data, but we added 3 additional driver variables, each of those with 28 months of history in there. And so now when we're building our model, what we're going to get is we're going to get 112 monthly data points that can then be incorporated into the model and built. So instead of just using 28, we have 112. And so this gives us more data to build a more robust multivariate model. But how did it use it? What did it do? You can't really tell. And so there is some advantages here. It's determining if these are really important to the model and if these data sets can really help train the model. But you don't get that kind of linear relationship that you would get here when we go up to our store count regression, that one store leads to 3,500 more sales. We're simply saying that store count is important and it was used in the model, but we don't really know how. And so there isn't this kind of one-to-one relationship. Now the advantage is I can build one model that has all of our potential helpers, and I can apply that across the board, and we'll see that in our future example in a few minutes. But what I don't get is this kind of one-to-one relationship that I do get by using regression, where I can see here's the actual linear relationship of how these are working. But that comes at a cost too, whereas the regression models require more input from the user and more decisions from the user, as opposed to letting Forecast Pro make those decisions for you. So there are pluses and minuses from using both. Now for our next 2 examples, we're going to look at how we actually apply these methodologies at scale when you have a full-scale hierarchy. And we'll start with the dynamic regression model, where we're going to build a couple of generic regression models that can be applied across your hierarchy itself. So here we are back in Forecast Pro with a new data set. This data set is our serial data set, and this actually ships with Forecast Pro, both the historical data as well as the driver variables file. So you actually have a copy of these. Now this data, unlike the last data, is weekly instead of monthly. And you can see it goes from 2020 through 2023, so it has about 3 years of historical data. And it is sales of different cereal. You can see they have a fairly complicated hierarchy. We have grand total, they have kids cereal, they have family cereal, and then they have adult cereal. This breaks down into their different product families, and then finally down into the SKU level. So this is a much more complicated process in the sense that we have a fuller hierarchy, and this is more representative of what you would probably be doing. You wouldn't be building these on a one-off basis. You would want to build a model that could be applied to a group of items or an entire subset of your data, where we'd want to try to automate this as much as possible. So we're going to use this data for both, again, the dynamic regression as well as the MML models to try to build how would we do this in practice. Now, in order for this to work, we need to load in the variables, these driver variables, but not just a single set. So in our last example, we had a single set. This was the price for this SKU. This was the disposable income that everybody used. But at scale, we actually need to load this in for every single item. So let's take a look at this in Excel. So here we are in Excel, and you can actually see, similar to our last example, we actually have multiple variables that go into generating a forecast. And you can see, similar to the last one, we have a price variable that we can use. We also have the number of stores that are selling. We have that as well. Here they have two other variables that are slightly different. They have display and feature. Display basically means in the store, is there some sort of promotional display that's coming up? So in the last one, we had kind of this promotional discount that we had here. This is similar to this, but is there some sort of display in the store itself that's showing off the product and discounting it? And then a feature, this would actually have to do with, is the store running some sort of marketing campaign? This is kind of a on-off switch. Is the store selling some sort of marketing campaign for this or not, some sort of promotion? So you can see that here. So we have very similar variables. We have 5 variables. But we need this for absolutely all of the items in our hierarchy. So I have filtered this just for this one SKU. So you can see I have 5 series for this one SKU. But if I go ahead and select all of these, you'll see I have the same variables for absolutely all of my SKUs. And I have it matched up to my product hierarchy itself. So if I were to create a model, whether that is a regression model or an MML model, when we use the variable price, the price for this SKU will be one thing, whereas the price for a different SKU will be a different price. And the price over here for this SKU will be different. And so I can create one model that uses price, but the actual driver will be different for each SKU that I apply that model to. So if I set up my explanatory variables this way, what this allows me to do is build either a regression model or an MML model that will be generic. So I could just, for instance, create a simple one that just uses price, but it will build a different model for every single item because we're using a different driver series representing price for each individual SKU. So let's see what that looks like in practice. So back here in Forecast Pro, I've created some of these simple models. So here in Dynamic Regression, you can see I have a price only, I have a price in display, a price in stores, or a feature in display. So I've created generic regression models that, again, will use just a single or multiple variables. I have auto dynamics turned on, so it's going to automatically fill in the rest. But I can then apply this en masse. So again, if we keep it simple, we'll just do a price only forecast. You can see I've put it here and it built my model for me where it's price, again, negative coefficient as I would expect. I increase my price, I lower my sales, and it has a whole bunch of other auto dynamic terms that Forecast Pro has automatically put in. But I could then come in here and I could right click and say apply this model to, for instance, I could do everything at this level of my hierarchy and apply the same simple model to absolutely every SKU. And it will produce a different forecast. So here, for this item, the coefficient is minus 9,500. For this item, it's minus 8,000 and has different autodynamic terms over here. Here, the price has a minus 3,000 in different autodynamics terms. And so what I'm able to do is create a generic regression model that I can then apply to multiple items, and then everything else is kind of done here. So it's not fully automatic. I still have to make a decision. So for example, I could come up here and say, you know what, for all the kids, I want to use price. But over here for the all family, maybe I want to pick a different regression model, and I want to do feature and display. So I can do my feature and display here on one of my all families, and then I can come over here and say apply model 2, and I'll do select. And we'll go ahead and show ancestry. And I'll select all of the all family items and say apply. And now you'll see for all the all family, we're using the feature and display model. Whereas up here for the kids, I'm using the price only model. And so what you would be able to do on scale is create some generic regression models that you could then post around and put on different SKUs or different product families, different groupings, different materials, different customers. But I could have these generic regression models that incorporate what I think are the important variables for those, but let Forecast Pro do the dynamics and fix everything else for me. And this allows me to, at least at some scale, apply my regression models for specific items. So if I'm able to bring this in, I can go ahead and do this. With the advantage, of course, being that I can apply models on scale as opposed to building them one at a time, which eliminates one of the biggest downsides of using these multivariate models, which is that they had to be built one at a time. If I take advantage of these autodynamics, if I build these generic models, I can actually apply them en masse, which will build a more robust model and can be applied at scale. For this last example, we're going to, again, look at how we would apply the multivariate machine learning model across the same data set at scale, where we could build a single model and apply it to all of the items within our hierarchy. So now back in Forecast Pro, how would this apply to the MML models? So once again, up here with machine learning, I've created two generic ones. One with just price only, which again, I could select just consider using price. Or more realistically, what you'd want to do is the all variables. This basically lists all possible variables, which we can go ahead and choose here for this. Again, we can see, it features some of these feature and display, price, feature, display. We can see that they're using these here. Again, we don't get the kind of linear relationship, but it's choosing which ones to use. But because I've listed all the variables and the machine learning algorithms will decide what it thinks is best, once again, I could just go ahead and apply this modifier to this entire level of the hierarchy. And what you will see is now each individual SKU is determining which of the variables to use, which ones are helping, which ones aren't. You can see this one has fewer, whereas this one, we come up here, this has much more in terms of the features. So it's going through in the machine learning algorithms and picking what are the driver variables it thinks are actually important to include in the model. And once again, it's simply adding that data to the model that's learning what it needs to do. And so we have a more robust methodology here. And so if you're considering machine learning as one of the options, this is much more automatic in the sense that I can just list all possible driver variables that I could use. Again, it's building, a different price for each individual item, and it's going to use those individual series, but I can then apply it across the board. And so if I want to build a more robust model, and I want it to be hands-off, so pick what I think is most important, the MML models are really a good choice for this. And it's something that you can really take advantage of if you want to try to incorporate some of these drivers without having to go in and pick which variables are most important for which individual item. Let's summarize some conclusions from this webinar.
So what are some conclusions that we can come to today? As we saw, multivariate models allow you to build more in-depth and complex models than just the univariate series, which rely solely on your historical data. And while they do require some hands-on work from you as the user to make them work, what we hopefully showed is that there's a lot of automation that can go into this, allowing you to apply multivariate models across your product hierarchy, not just on a one-off basis. This makes them much more useful at scale, and they allow you to build more complex and accurate models if you have these outside drivers that you want to try to take advantage of. Okay, just a few notes about this webinar in general. We did use Forecast Pro Track version 8.3. This is our most recent and up-to-date example. This includes all the multivariate models that we saw. We also used some of the sample data that came with 8.3, including the serial data, which you have access to. If you would like to learn more about Forecast Pro Track or this version of 8.3, whether you have it or don't, we do allow you to schedule live demonstrations of Forecast Pro. We can use your real data. They usually take about 60 to 90 minutes, and we can show you more about this. And if you would like some more information, please put some notes in the chat, and Franklin will take advantage and make sure to contact you about that. Or beyond the demos, if you want to schedule additional training to use your real data and go over any of these multivariate examples that we covered, or any other topic for that matter, obviously please reach out. That's my primary role here at Forecast Pro as a trainer, and I'd be happy to help with any additional training that you would like. And now, as we mentioned in the beginning, we are running these webinar series once every quarter. Our next webinar series will be in August, and it will cover external data and how to use that. Again, this will be posted on our website on our events page, but my colleague Franklin will provide you with a link directly if you want to sign up for that webinar. Or as mentioned, we do run a parallel webinar series on more of the models and statistics. We are run in June that will also cover multivariate models, just like we covered here today, but it will really more deep dive into the model building and the statistics themselves. So I would highly recommend that you sign up for that. Again, Franklin will provide a link for you to see that. And we're going to wrap up this webinar with your questions. So please, if you have not typed in any questions into the chat up until this point, do so now. Franklin has been monitoring them, and we're going to dive in and start answering your questions. If I don't get to your question during the Q&A session, don't worry. We will reach out and contact you after the webinar. So with that said, let's dive into the questions.